Good day everyone. Today I will discuss our topic, Part 2, Differentiation of Trigonometric Functions in the Differentiation of Transcendental Functions topic under the Differential Calculus. Our module objective for this topic: after the completion of this module, students should be able to, number 1, interpret and solve the differentiation of trigonometric functions, and define and solve the differentiation of inverse trigonometric functions. Differentiation of trigonometric functions. So the following formulas are used for differentiating trigonometric functions. The same value denotes an arbitrary differentiable function of x. Formula number 1, d over dx sine u is equals to cosine u du over dx. Second formula, d over dx cosine u is equals to negative sine u du over dx. For our third formula, d over dx tangent u is equals to secant squared u du over dx. For our fourth formula, d over dx cotangent u equals to negative cosecant squared u du over dx. For fifth formula, d over dx secant u is equals to secant u tangent u du over dx. And for our last formula is d over dx times cosecant u is equals to negative cosecant u cotangent u du over dx. Sample problems for differentiation of trigonometric functions. Sample number 1, find dy over dx if y is equals to sine 4x. We note that y sine 4x takes the form of y is equals to sine with u is equals to 4x. So here we will use formula number 1 because this one is in sine form, which is equals to d over dx sine u is equals to cosine u du over dx. Then dy over dx is equals to cosine 4x. So sine 4x will be converted to cosine u. So our u is 4x. That's why it becomes cosine 4x. And d over dx du over dx, so this is 4x now. So we need to differentiate this part also. So then cosine 4x times 4. So 4 comes from the differentiation of 4x d over dx. So our final answer for problem number 1 is equals to cosine 4x times 4. For problem number 2, find dy over dx if y sine cube 4x. So if we rewrite y equals to sine cube 4x as y equals to sine open parenthesis of 4x cube, then it takes the form of y equals to u raised to n. So this is a power formula from our previous topic with u equals to sine 4x and n is equals to 3. Those, our equation now will become dy over dx equals to sine cube 4x d over dx times sine 4x. So this is our u. So we will use now the power formula and the sine u formula. So 3, so this comes from the sine cube here. Then sine squared. So squared here comes from the power formula, which is n minus 1. So equals to 3 minus 1. So this is now 2 times 4x cosine 4x. So sine u cosine 4x, then d dx 4x is 1. Then 3 sine squared 4x cosine 4x times the differentiation of this part, 4x d over dx, which is equals to 4. So our final answer for problem number 2 is 12 sine squared 4x cosine 4x. Our next topic, differentiation of inverse trigonometric functions. So the following formulas are used for differentiating inverse trigonometric functions. The symbol U denotes an arbitrary differentiable functions of x. Formula number 1, d over dx arc sine u is equals to 1 over square root of 1 minus u squared times du over dx. Formula number 2, d over dx arc cosine u is equals to negative 1 over square root of 1 minus u squared times du over dx. Formula number 3, d over dx arc tangent u is equals to 1 over 1 plus u squared times du over dx. Formula number 4, d over dx arc cotangent u is equals to negative 1 over 1 plus u squared du over dx. And formula number 5 is d arc secant u equals to 1 over u times u squared minus 1 times du over dx. And our last formula is equals to d over dx arc cosine u negative 1 over u times square root of u squared minus 1 times du over dx. Sample problems for differentiation of inverse trigonometric functions. Sample number 1, find dy over dx if y equals to arc sine 3x. Since y equals to arc sine 3x takes the form of y arc sine u, where u is equals to 3x. Those will use the formula number 1, which is in arc sine form here. Then dy over dx is equals to 1 over square root of 1 minus 3x squared. So 3x our u here times d over dx times the u 3x. Then we need to differentiate the 3x times d over dx. So this is equals to 3 here. Then we have to simplify this one, 3x squared. 3 raised to 2 is 9 and x raised to 2 is x squared. So our final answer for problem number 1 is equals to 3 over square root of 1 minus 9 x squared. So for problem number 2, find dy over dx if y equals to arctangent x over 4. So we'll use formula number 3 because this is in arctan form. Then dy over dx is equals to 1 over 1 plus u squared. So our u here is x over 4 times d over dx times u. So our u here is x over 4. Then 1 over 1 plus x squared over 16. So this is x raised to 2. Then 4 raised to 2 times 1/4. So 1/4 came from the differentiation of d over dx times x over 4, so which is equivalent to 1/4. So our final answer now is equivalent to 4 over 16 plus x squared. So this is our final answer for problem number 2. Sample problem number 3. A ladder 25 feet long leans against a vertical wall. If the lower end is pulled away at the rate of 6 feet per second, how fast is the angle between the ladder and the floor, changing when the lower end is 7 feet from the wall? Solution. In the figure, we let x is equals to distance of the lower end of the ladder AB from the wall CB. Then let the theta equals to angle between the ladder and the floor CA here. So we want to find here the d theta over dt when dx over dt is equals to 6 feet per second and x is equals to 7. So since cosine theta is equals to x over 25, then theta is equals to arc cosine x over 25. So differentiating with respect to time, so d over dx arc cosine u equals to negative 1 over square root of 1 minus u squared du over dx. So we use the formula for arc cosine form. Then d theta over dt is equals to negative 1 minus x squared over 625. So this is our u. So this one comes from x over 25 squared. So this equals to x squared over 25 squared, which is 625, times 1 over 25 t over dt. So this is in terms of time. Then substituting x equals to 7 and dx over dt is equals to 6, d theta over d time is equals to negative 1/4 radians per second. The minus signs indicates that theta is decreasing. This ends our presentation for part 2, differentiation of trigonometric functions. Thank you for watching. Our next topic for part 3, differentiation of logarithmic functions, will be uploaded separately.